This video's topic will focus on archiving with the SIP archival method. Knowing when to position SIP versus table-based archiving will drastically speed up the process. We will start with a brief introduction of SIP archiving. This will explain what a SIP package is and how we use them. The topics following will be technical, starting with partition keys and wrapping up with the configuration of encryption. Each of these topics you will get a chance to configure during the hands-on lab. The archiving process differs from us using the table-based method. First, we need to understand the data and define what we want to archive. Once we have done that, we will generate the data and the metadata from the applications. Note that I said applications. One SIP package could contain data from multiple apps. Once we have created these packages, InfoArchive can receive the data. The data can be anything from completely unstructured content, database content, or a combination of both. Regardless of the type, a SIP container will be created and ingested. InfoArchive picks up the package and begins the archival process. First, it receives, ingests, and finally commits upon success. This archiving method requires a SIP package. The term SIP stands for Submission Information Package. It's composed of two parts. The manifest describing the SIP package, such things as SIP creation date, source, ID number, among other things. The second part is actually the payload. The payload consists of both unstructured and structured content. The payload will contain a number of business objects called AIUs. These are individual records such as a phone call, invoice, or documents. Let's break down the AIU even further. Each AIU must contain metadata and optionally may contain unstructured data. The metadata for all the AIUs, which is each individual record, is stored in a single XML file, seen on the right. Any optional content information will be a collection of any files in any format, such as a PDF or MP3. What you're seeing here is an example of one of the metadata files. If we look at highlight number 1, this is going to represent the AIU, or a single record. The red number 2 is showing us where a pointer to one of the unstructured content files live in the SIP package. Use this next content as reference, just to reiterate what a SIP and an AIP package actually is. Now that you know what we actually do archive, it's important to know where the information is stored. At a high level, we can break down InfoArchive storage into three components. First, let's talk about the system data. Now, this is going to hold any of your configurations. It'll register all of the AIPs, break down the partition criteria, and all of the security information. The next repository will be our metadata repository. Now, this is our XDB library, where the SIP XMLs are stored, the PDI XMLs, and other references to the objects. Now, there is a fourth repository that you don't see on the graph here, but this is the compliance repository. Any retention and hold information will be stored in there. This is usually a relatively small database. The final and the largest section is going to be the file store. This is where we'll do our backups of XDB. This is where all the unstructured content will lay, any of the ingestion logs, any of the gzip logs that are created, any analytical renditions that are created. InfoArchive uses a fairly unique searching structure to be able to retrieve content as quickly as it does. What it does is does a two-tiered search mechanism. The first tier will find the packages or the AIPs that might contain the results. Now, this is going to use the partition keys that we'll set up later in the video. This will quickly narrow down the scope of the search. Now, tier 2 will actually go through all those packages, all those individual results, and this is going to use indexes created. One search example would be involving invoices. Now, the first tier will search through all of the AIUs that might contain a partition key, usually around something like a date, so invoice date creation period. Once it's found a collection of invoices in that date, it will then use the indexes to be able to find the specific data searched. To further illustrate this, let's think about searching for a customer ID in a specific month of a year. The tier 1 will find all candidate AIPs that are all around the same year that we're searching for. So this will be February of 2016. Now, once it's found a collection, let's say 3, it'll then scan those AIPs. The AIPs are returned. It'll then use indexing to find the specific customer ID we were searching for, example, Conrad. Now let's dive into partition keys. So again, this is the first tier of search that we have. It's going to be computed during ingestion using an XQuery that you have to write. It will be stored in the AIP object within the system data repository. And basically what this is going to do is define the range of data in an AIP. Now keep in mind that an AIP can have multiple partition keys to satisfy a range of different criteria. There are several types of partition keys, everything from a date time, string, integer, long, and double, etc. seen on the screen here. Now, as you can see as an example, the AIP ID of number 1 is going to be using January 1st of 2011 to January 31st of 2011. So this will happen during a searching. It'll grab all the AIPs that exist within that range and return them for the second tier of searching. In order to set up a partition key, you have to put this in the configuration XML. So for an example, what you're seeing here, it's going to be doing the date time 01 ID. And what we're going to be doing is declaring a namespace and giving it the path of where the object actually exists. So in this situation, that XQuery XPath will be objects, object, and then the date time, which is creation time. I made a comment at the beginning of this video that's important to understand the data before we ingest it, and this is why. In order to set up your partition keys, you need to understand what exactly you want to search for. And 3 common partition queries are things like a minimum, that could be the start of a time, max, the end of a date range, or something like values, which could be categories or a set of integers. Since we will be writing these partition key queries in XQuery, we can use common XQuery optimizations, such things as ascending or descending. This can help create faster min and max key queries. For example, you can see here that if we're going to search for a minimum, we'll use the ascending command, and on the maximum, we'll use descending. Now, our second tier of searching will be using the index. Again, this is computed during ingestion. It'll cover the data all in one single AIP or record. And one AIP can have many indexes defined, again, to satisfy a different wide range of search criteria. We do have 2 different index types, path value indexed and full text indexed. Let's dive right into a path value index example. This example here is for a Twitter application, so we're going to be indexing a tweet ID. The XML structure will define how the index is created, including things from the index name, as well as the path, whether it's a unique key, concurrent, or if you want to build it without logging. The path is very important. So you can see here that we will be putting in our namespace and then the XPath. So for example, this will be searching for objects, object, and then ID followed by the type, which is string. The alternative to doing a single index on a field would be to set up full text indexing. Now, what you're seeing here on the screen is an example of using full text indexing for the element name of text. The configuration for this full text index will be in the same XML as the basic indexing, just adds a few more flags. Now that we've gone through what SIP archiving basically is, partition keys, indexing, let's step into how to configure the queries themselves. So this next section will be dedicated to search configuration. We will go through 3 different parts. The first one being the AIC configuration. Second is the query configuration itself, and the query quota. The AIC, which is going to be the archival information collection, what we're going to do is set up a definition of the collection of AIPs returned. The search criteria you see on the screen here will be used to actually search through those AIPs. So what we'll do is we'll give it a name, a label, the type, and any minimum or maximum attributes if applicable. Let's examine what the 190-AIC XML file actually looks like. So as you note, as we scroll down to the bottom here, you'll see things like call start date, call end date, and customer ID. So all three of these fields will actually be used to search the AICs. Call start date will have minimum and maximum entries, where things like the customer ID will just have type of string. If it is a primary key or a partition key, you want to place the value in there. So P keys value attribute, value 01 for customer ID. One important thing to note is this file, whatever entries you have in here as a criteria, these will show up in the UI wizard. So when you create a new search, the new search gives you certain options to search your AICs. These fields here will actually populate that wizard. Now that we know how to search a collection of AIPs, let's look at what we actually do to query the backend. This is what we do, the query configuration. So first important note here is that we're going to give it an entity path. An example of phone calls, it'll be calls, call. This entity path will show our search where to actually find the records in the PDI. Along with the entity path, we will pass in operands. Now these operands will have four important parts. First one being the name, second being path. So in the previous example, we talked about calls, call, and now a path of call start date. So this will just be appended to that. We will also pass in the type and then whether the field is indexed. So let's walk through an example. This file is going to be under 220-query.xml. Any tags with the $ in the parentheses is going to be a holding, so there's no need to ever change those unless if there's some customization needed. But if we scroll down a little bit under the PDI configs, we're going to see our schema and an entity path, like I mentioned above. So this is calls, call, and operands. Now this is showing just one operand, but you're more likely going to have several to a dozen. This will show call start date, the path of that, the type, and the fact that it is in fact indexed. The next part of this searching is going to be our query quota, and this is under the file 210 queryquota.xml. By default, these will be set as 0, which means that there's no limit. But what this allows us to do is put in restrictions on what amount of content is actually returned. The amount of AIPs that it can span, the amount of AIUs that it'll span, and how many AIUs will actually be returned by a result. Again, 0 means no limit. So as of this point, we have covered partition keys, indexing, how to actually set up the querying. Now we're going to go into the result helper. Now the result helper is important because this will define what the wizard in the UI will actually display. For each of the values that you want to display to the user, you need to have an element tag consisting of a name, a label, the path, and what kind of type it is. Let's take a second just to examine what the template looks like. We will start by passing in the namespace for the PDI. After that, we will have repeating elements of elements and groups. An element example would be something that is a single variable, single value variable, such as a representative ID. This is going to be type of integer. It will also pass in the path of this. Keep in mind that the name and label are two different fields. Label will be the human readable format that gets displayed, and the name is something the system will use in the backend. Now, if we want to set up something for repeating elements, we have to set up a group. So our group tag cannot be nested, but what it will consist of is a name, a label, and a path. Now let's look at an example. Think of several authors on a document. You're going to have repeating first name and last name. So in this example, under one single group, we will have author 1, John, author 2, August. Let's look at a full example now. So we'll start with the opening tag of group. You give it the name of authors, the label of authors. We have to pass in the path, and then repeating elements, first name and last name. Now that we've covered how to search the AIPs, how to query the backend, and also bring the results back to the users, we can look at now creating the actual holding. The term holding is just a logical separation where we can archive data of similar characteristics. So this could be an example of things from the same application or maybe from the same line of business. One important thing to note that an application layer can contain several holdings, as well as several holdings can exist for a single data type. And this is done to be able to return different result sets or provide different security access. The term holding is specific to the SIP-based archiving. Table-based archivings do not use this type of configuration. The holding will define where the storage area is, what retention policy by default is applied to the packages ingested, what the ingestion sequence looks like. Some of the main drivers for creating a specific holding need to look at what kind of data types will be archived and if the data needs to be separated or isolated. The holding configuration is broken apart into different files. The first one we'll speak about is the holding configuration of stores. This file will determine where each component of the ingested package will actually be archived. The next important configuration file will be the hashing file. This is going to explain whether the content hash validation is enabled or not, and also whether the PDI hash validation is also enabled or not. The next configuration file will be our PDI and ingestion processing. This is important if we're going to create more than one holding for an application. This will tell InfoArchive what ingestion process to use for the specific format, as well as what PDI configuration to use for a specific schema. And finally, we can set up a holding configuration for retention policies. What this will do is put by a default policy on the packages as they get ingested into the system. Now that we have configured holdings, let's look at confirmations. A confirmation is simply just a message generated from some kind of activity from an AIP event. Now, a confirmation can be anything for a single event. It can be 0 to n confirmations for these single events. The content of each message is configurable, and the specific event will only be processed once per each AIP. Now, this is usually used to send messages back to the source application, indicating that the content actually has been archived, or notifying other business applications that there is new content in the archive. Let's look at the different types of AIP events. At a high level, what the confirmation job will do is it'll look for any events that were listened to. It'll generate the confirmation audit event, generate the confirmation, and then update the AIP and send the confirmation date for the event. We can also configure the query scope of the confirmation, so we can have it at a SIP level or the PDI level. You can see here is an example of the default confirmation query. There are placeholders for query variables as well as AIP properties. So this chart here is showing you the query variables. And this is an example of accessing the AIP properties through an external call. Finally, we have a list of delivery channel parameters. Each of these can be used in the confirmation message. What you're seeing here is an example of the default confirmation setup. We'll pass in the name. In this case, it's going to be placeholder of holding-confirmation. And you can see our delivery channel parameters at the bottom. Now, it's quite common for an analytical rendition to be created. Now, this is just a file generated from the PDI in a format such as JSON, XML, or CSV. This is typically for consumption by Hadoop and stored in the file store, something like Isilon. The rendition will normally be generated during ingestion or on demand by a REST call, and it'll only be removed when the AIP is purged. We can create the rendition using XSLT. The XSLT can pass in certain parameters such as position, is last, and it will use XQuery to be able to query the entire PDI. We can examine a brief example of using XSLT to create a CSV rendition. We will start by adding our headers by call start date all the way down to representative ID. and the data itself, which will be done through this bottom row's return call, local add row. Now this is just showing you the XQuery needed to actually bring back the results for the XSLT. If we look at the example of the XSLT, we'll see the variables being passed in to actually generate our format. The final topic in our SIP ingestion discussion today will be around encryption. InfoArchive 4 supports encryption of the following 4 types. We can either do the metadata contained in the PDI XML, any unstructured content, the SIP after it's been received, and the AIP contents. Keep in mind there are a couple limitations to the metadata, and only one text element or one of its attributes can be encrypted. When we're doing search criterion, only equal and not equal will be able to search the encrypted data, and the holding object must accept the encrypted SIP format. Now, in order to control who can actually see the decrypted data, we need to configure the AIC object, and we will define on the decryption method. So in this example, you'll see that we're going to decrypt given access to group A and group B. To configure the type of encryption, we will create a crypto object as seen here on the screen. In this example, we'll pass in a key size, the security provider, which this one will be Sun JCE, the encryption mode, as well as the padding scheme. To actually encrypt the metadata, we will do is alter the PDI-crypto XML. This file format will look very similar to the PDI XML. The only difference is we will actually give it an ID of data encrypt, but we will pass in the path of object, and then whatever the metadata tag is that we wish to encrypt. Again, this is only for metadata. For encryption of contents, we need to return all of the RI keys. This example here, again, is in the PDI crypto XML, and this will be showing how we will encrypt the content itself. By using the select X query, we will be returning the RI keys of the encrypted content. If we wish to index any of the encrypted fields, we do need to alter the indexing string. So the type changes from string, which is what it would have been in the PDI.xml, to using a hash function. Now you're seeing that across the bottom there, where it says hash &LT string. So this will pass in the hash value of type string, and this will allow us to encrypt it. This is showing a full example of what we just spoke about. So again, we're going to create the index creator. We're going to pass in the name of the path value index, give it the path, but you'll see that there's a hash value in there instead of just string. And since we will index the hash value, we will also search on the hash value. So now when we actually do want to searching on the encrypted data, we need to change the query configuration to type of date time or type of integer to type hash. So in this example, that red number 2 is showing where type hash for representative ID is now. And the path has also changed, where we pass in a hash function. In order to process the search results, we also have to pass in a custom query template, which is going to decrypt the encrypted values. So this template will be appended to your search configurations. Now that we've used a template, we can actually declare a function of decrypt tree. And this will allow us to do is pass in the specific elements we want to decrypt and use the function written in the template to decrypt it. For example, case element representative ID. We'll return the element with using a decrypt function and return the decrypted value of that hash. Now, this concludes this demonstration. This video is intended to be used prior to the SIP ingestion lab. For additional information, please review the documentation that comes with InfoArchive as well as the lab materials. For additional information, please use the InfoArchive documentation provided as well as the lab guides.